Hello everyone, welcome to our project. Our project is to design, prototype, test and deploy a full-stack web application related to the coronavirus. Once designed, this will update the details about the number of affected people. It should be a system that processes, analyzes, and visualizes data and statistics so it is convenient for the viewer. Moreover, the design involves a requirement for a large and real database. We hope it helps create awareness of the situation in the nearby areas and help them in reacting towards the disease. Since our focus is on the current COVID-19 pandemic, a good amount of information regarding the virus itself is important. Research learnings on the science of the situations are vital, and WHO, the World Health Organization, provides research paper databases on their website. The WHO situation reports are also a key informer of the condition, and these are all provided in the hyperlink. The datasets of the confirmed cases, recovery cases, and deaths in different countries and regions are available from various sources, but we believe the most reliable ones are found at WHO and health commissions of other countries. The data associated with the current outbreak of the virus is large in quantity, so there is a huge process of gathering information, sampling out the information needed by categorizing different topics, and finding out the required terms. So there is a requirement for testing the applications and verifying its reliability. These are all key factors to understand before completion. Additionally, in order to achieve the goal of creating the application, we found out using distributed version control systems like GitHub has many key advantages and is efficient. As a group, we also decided on technical systems for implementing the application, which will be presented to you in the next few slides.
For the design of the front end, we think that a dashboard is the most appropriate way to visualize the huge amount of data about the coronavirus. We want to show some key figures and rank the countries according to the number of cases. We also want to visualize the figures on our world map. We believe having both the numbers and visualization can help in decision making. Besides the current situation, we believe historical data is also important. We decided to visualize the time series data in charts. The cumulative numbers give an idea of the growth rate, whereas the daily numbers allow us to see if the situation in a country is under control. Finally, we include a country-wide live tracker to display instant figures that are drawn from an API. To implement the dashboard, we tried many packages to see what we can use so that we do not reinvent the wheel. As our application requires retrieval of data, we use with ducks and dunk to set the states and dispatch actions once the asynchronous JSON fetches are completed. We use Material UI to handle the presentation of data and style our components so that they all have a consistent look and feel. Its grid component is particularly useful in the dashboard layout. We use Plotly at .js to draw charts of the time series data and React Simple Maps to render our bubble map with Tooltip. We use Firebase to connect to our database and publish our web app onto the internet. We also use Axios to handle our asynchronous JSON requests.
For our COVID-19 web app, we needed data that was automatically updated every day that the web app can reflect. We decided to use a third-party trusted source as collecting data from all countries ourselves would be too much work. Initially, we thought to data scrape a website to collect the information, but decided it would be much easier to use an API that would provide us with a JSON file with all the required data. However, we needed consistent data and a data structure that the web app can read. To solve both these issues, we created our own NoSQL database in Firebase. To achieve this, we used Node.js to extract the data from the API, transform it into a structure and format we need, and write it to the Firebase real-time database. For example, this allowed us to add in country codes from other API and also format the date correctly. This was successful for initializing the database. We still needed to automatically update the database every day. To achieve this, we used cloud functions in Firebase. This feature automatically runs back-end code at a set time every day. In our case, the database is updated every day at midnight. Every day the database is reinitialized so that the most recent updates are included. This is reflected in the web app.
Now to discuss about testing, as we know we have two types of testing, that can be a manual testing and an automated testing. So first of all, we have performed manual testing, which included checking of links that are propagating properly or not, if we can see our views rightly or not. Then also one manual testing that we did was about bootstrapping for various kind of pieces, with maximizing contents, with minimizing content, if we can try for mobile, if we can try for laptop, if we can try for an iPad. So this was a type of resolution testing which came under manual testing. Here also we included the testing which included the field selections. If you click on a particular country, it should display the data of that country as well only. So that was one of the manual testing. Now moving on to automated testing, we were taught, we used React for the normal testing, and we also used React's library, which was named as enzymes, which we used for simulating some steps. So for if we go for the React normal testing, what we did was we have used some APIs and the database to and also a API to point to our database, which is Firebase. So for API testing, we used a React normal testing library where we could just hit that API and maybe get and maybe confirm if we can retrieve that data or not. That was our React normal testing. And for enzymes, for simulation, we used enzymes. So the simulation was we wanted to know if we click on a particular tab, does it navigate to a particular component or not. For example, now we have multiple components, so if we click on one component using Redux, the other component should change as well. This was what we simulated.
Discussing about the project management, we had group meetings which were virtual or physical. We just had an opportunity to have one physical meeting where we just sat together and decided on the first iteration of this project, about the topic of the project, and how to submit a proposal for the first iteration of the project implementation. Then most of our meetings were virtual, which were held on Zoom calls, and where we discussed about the topics with what we have covered till now and what are we supposed to do further. Then the group meetings also included sharing links about the tutorials which each one of us found important so that it could contribute to each other's learning. These were one of the important things in our group meetings. Then we planned a schedule, which you can see in the diagram. We plan a schedule from 10th of April in such a way that we end our entire development phase and testing phase till the 24th of May, which was a few days before the deadline, so that we could improvise if we need to do that. That was the plan, and fortunately it worked good till now, and we were in a good position to demonstrate our application. And then after the schedule, there comes GitHub collaboration, which played a big part in the group discussions, in the group collaborations, where each one of us could develop a separate entity and then upload it on GitHub. Then others could see them, others could commit some changes in them and make some modifications, which led to a better group collaboration at GitHub. So GitHub really made it better for us in terms of development.
I'm now going to demo the COVID-19 dashboard. First, let me click on this link to access the dashboard. It is now loading the data from our Firebase database. The database, as Toshiki has mentioned, is updated daily. So you can see that the data is up to yesterday. And now I'll go through the website features. You can see that there is a header, some key figures, the total number of cases, the total number of deaths, the total number of recovery. These are shown at the top to draw users' attention immediately to give the idea of the magnitude of the numbers. And then there is a last update date, which is also an important information. So we've put it here. And then we have the list of countries ranked in the total number of cases. In the middle, you can see a world map with some bubbles. And on the right, there are two charts. Finally, we have a country-wise live tracker at the top right-hand corner. And now I'll go through the features one by one. When the dashboard is first loaded, you can see that the global figures are shown. These figures and the data showing in the graphs are for the whole world. To look at the figures of a specific country, you can click on a country on the list like this, or you can click on a bubble on the map. The key figures and the charts will be updated automatically with the country-specific data. If you want to go back and look at the global figures, just click on the title COVID-19 dashboard, and you will get back the global figures, and of course the graphs are updated as well. The list of countries on the left-hand side is very useful in giving users an idea of which countries are currently having the highest number of cases and the magnitude of the numbers. Navigating on the list is very easy. You can go through the list by clicking on the arrows, left or right. Or you can go to the bottom of the list, or you can go to the top of the list. It's very easy. And when you see that there is a country that draws your attention, you can click on it, and the whole dashboard will be updated to show you the details. In the middle of the dashboard, a world map with bubbles allows the users to have a visualized way to interpret the data. You can move your mouse pointer on top of the bubbles to see the country name and the number of cases that it has, and click on the bubble to update the whole dashboard for details. You can also zoom in by double-clicking, like this, and pan by dragging, like what I'm now doing, so that you can go to see the specific country that you would like. And then you can click on the country bubble for the details. So you can navigate your way on the map. And then we'll take a look at the charts. The line graph is showing the cumulative number of cases, including the confirmed cases, the death cases, and the recovery cases. The data is showing from day one that the country has data until yesterday. The bar chart, on the other hand, is showing the daily number of cases. So you can see sometimes it goes up and then it goes down. With the visualization, we believe it is much easier for users to quickly have an idea of how the situation of a country is and help them to compare the situation between the countries. It is much easier to do it visually rather than by numbers. Both charts are interactive and support zooming in and out, so you can hold your mouse to highlight the particular time frame that you would like to focus on. And if you need to, you can zoom back out. The same goes for the daily number of cases. In addition to the dashboard, we have prepared a country-wise live tracker. You can access it at the top right-hand corner. This is for you to have a handy quick glance of the situation of a country by typing in the first few letters of the country name, like New Zealand. The data is retrieved instantly from an API. So let's try another country, say India. Here we go. So we'll see the latest update of India. That's all for the demo. So this concludes our presentation. I hope you like our COVID-19 dashboard. Thank you for joining us. Goodbye.